Hey everyone, welcome! Today we're embarking on a seriously fascinating journey. We're going to start by looking at these grand, sweeping ideas of human society, how we live, interact, and get shaped by our world, and then we're going to zoom all the way down to the exact mathematical coordinates of where you are literally sitting right now. So let's dive right into this explainer.
Okay, here's our quick roadmap for today. 1. Decoding human society. 2. The 5 exploration themes. 3. The magic of maps. 4. Flattening a sphere. And finally, number 5, coordinates, climate, and time.
Starting off with section 1, decoding human society.
So before we can physically navigate the world, we've got to understand the human elements that actually make up this world we live in. It all starts with this massive foundational question. How do we solve the problems facing humanity, right? I mean, we live in an age of phenomenal possibilities, but also unprecedented challenges. We're seeing this incredibly rapid, world-altering technological progress on one hand, while on the other, our societies are dealing with intense conflicts and an environment that is under immense stress. Figuring out how to live in peace and harmony while protecting our shared Earth, that is absolutely the fundamental challenge of our time. And to solve these problems, we really need to understand the society that created them in the first place.
And the reason the answers to those big questions aren't simple is exactly because of how differently we live. Just think about the sheer contrast. On one side of the spectrum, you have quiet, peaceful rural homes nestled by a lake under the shadow of a mountain. On the other, an incredibly dense, bustling, high-tech urban environment just packed with glass skyscrapers and gridlock traffic. The needs, the deep-rooted history, and the daily lives of the people in these two places are just vastly different. Decoding this massive spectrum of human existence is exactly what the field of social science is all about.
Moving right along to section 2, the 5 exploration themes.
To make sense of all this overwhelming complexity, we definitely need a system to organize our understanding. The crucial point here is that instead of getting intimidated by dense academic words like sociology or anthropology, we can just use 5 broad, really accessible themes. We explore how our physical land shapes us, how the tapestry of our history guides our present, how our cultural heritage forms our identities, how we handle governance and democracy, and finally the economic life that sustains us all. Honestly, these are the 5 pillars that hold up human society.
Now, what's really fascinating here is the core philosophy. Social science isn't rigid like, say, a controlled chemistry experiment. It's a dynamic adventure. It brings all these diverse fields together, which we call multidisciplinarity. You might be studying geography, but suddenly you're discussing an ancient poem or a historical chess game. Why? Because real life doesn't happen in neat, isolated little boxes. Life constantly mixes history with economics, culture, and geography. So our approach to learning about the world should absolutely mix those elements too.
That brings us to section 3, the magic of maps.
Let's see how we build from those abstract concepts into highly practical tools. Imagine you're visiting a small city for the very first time. You've just stepped off the train at the railway station and you urgently need to find the bank. Without a guide, you'd be totally lost, right? But a simple map is our most basic, magical tool for navigating human society. It's literally like a treasure guide, showing you exactly where things are and the relationships between them. But how on earth do you fit a massive, sprawling city onto a tiny piece of paper or, your phone screen? You use a map's first core component, scale. Scale is simply a ratio. It means that a single centimeter on your page could represent 500 real-world meters on the ground. By using scale, mapmakers can shrink the entire world down to something you can slip right into your pocket, all while keeping all the distances perfectly proportional.
Next up, once we have the size right, we've got to orient ourselves using the cardinal directions. These are the 4 main points of a compass: north, east, south, and west. Typically, maps will have a small arrow marked with an N pointing toward the top. Once you know exactly where north is, you know which way to walk from the hospital to the market or the bank to the museum without just walking in circles.
Finally, we have symbols. Think about it. A mapmaker can't draw every single brick of a police station or every leaf in a forest, right? That would be impossible. So we use standardized symbols to pack tons of vital information into a really limited space. Government bodies, like the Survey of India, create fixed sets of symbols. We're talking simple lines for railways, little crosses for hospitals, or shaded areas for water. It's basically a universal visual language that lets anyone read the landscape instantly.
All right, moving on to section 4, flattening a sphere.
Now that we know how a local map works, we face a much bigger problem. What happens when we want to map not just a city, but the entire Earth? Here is the fundamental geographical dilemma. The Earth is a 3-dimensional sphere, well, almost a perfect sphere.
But our maps, books, and screens are two-dimensional, flat surfaces. If you've ever peeled an orange into large pieces and then tried to press that curved skin completely flat against the table, what happens? It tears, it stretches, it distorts. This perfectly illustrates exactly why flat maps can never perfectly represent our planet. To get a true, completely undistorted view of the Earth, we really have to look at a globe.
Which perfectly sets up our final section. Number 5, coordinates, climate, and time.
Whether you're using a globe or a flat map, you still need a way to tell someone exactly where to find you on this massive planet. Think about how you locate things in everyday life. If you tell a friend to meet you in a crowded market, you might say, "Hey, meet me at the 7th shop in the 5th row." You give 2 intersecting points of data. Or if you play chess, you know that moving a piece requires a letter and a number, like moving a pawn from D2 to D4. A map uses this exact same logic. We need 2 specific, intersecting values to pinpoint any location on Earth. That's our system of coordinates.
The first coordinate we use is latitude. Just imagine horizontal circles drawn around the Earth, totally parallel to the equator. The equator is 0 degrees. As you travel north or south away from it, your latitude increases up to 90 degrees at the poles. But what's really fascinating is that latitude directly dictates your climate. If you're near the equator, you live in the hot torrid zone. Move further away, you enter the moderate temperate zone. Keep going all the way to the poles, and you hit the freezing frigid zone. So latitude isn't just an abstract number, it's quite literally the weather outside your window.
The second coordinate is longitude. These are the imaginary vertical half circles running from the North Pole down to the South Pole. We measure these moving east or west from a starting point called the prime meridian, which sits at 0 degrees and passes right through Greenwich in London. And here's where it gets incredibly cool. Because the Earth spins on its axis to face the sun, your longitude perfectly dictates your local time. When it's breakfast time on one line of longitude, it's the middle of the night on another. Longitude literally tells the time of day.
It is just truly amazing to realize that brilliant ancient minds, like the scholar Aryabhata, were already grasping these massive concepts centuries ago. He understood the spherical nature of our incredible home, suspended in space, way back around 500 CE. It just goes to show we've been striving to decode our world for a very long time.
Which brings us to the end of our explainer. We've gone from the massive social themes of humanity all the way down to the invisible grid that wraps around our entire planet. So, I want to leave you with a quick challenge. What are your exact coordinates right now? Seriously, open up a map app, find your latitude, find your longitude, and see your literal mathematical place in our vast, complex world. Thank you so much for joining me on this exploration, and keep learning.